Hi everyone, welcome back. Let's look at what's going on here with the differentiation. I've called it a series mixture. It's not that hard. Now if you want more about it, below I've got a link to the playlist with a lot of videos I've made previously on differentiation. Making this one specifically to think about what people need probably in India and Pakistan and Bangladesh, Indonesia, what's going on in your country and what do you need. So this one is where you go a bit tricky, but not too tricky. I'm also going to put a playlist on integration involving all of these as well. So there's heaps of videos there. So if you find this too hard and you're not ready for it, go back to the playlist and watch the first, the second, the third video. Another thing you can do though is also just look on the screen and see what I've got there. And go, well, I know how to differentiate sine. I know how to differentiate these, but I haven't dealt with logarithms, natural logarithms yet. So always have a look through what you can do. Now, if you can watch more of my video, leave it running a bit longer, that'd be great. If you want me to keep going, I need the support with the view hours. So have a look what's going on here. Most people are okay with writing y dash. Now, just in case, different method of writing it was, or the original method of writing it, closer to the original, was the y dx. But instead of writing the y dx, I prefer to just put a little dash there. Much quicker and easier to write. Now, I have all these little tricks I talk about. And I talk about the insides stay the same. The insides stay the same. And it applies all over the place. The insides stay the same. Well, what I mean by the insides, there's the inside there. I could put a red line under. There's the inside. On this one, there's the inside there. I can put a bracket around it because a lot of people don't understand. When you write an exponent, there's actually a bracket around it. Now, if the exponent was just 4 or just x, we don't have to put a bracket around it. But when you're putting an addition or subtraction to it, it really has a bracket around it. It's implied in everything. So that's the inside there. There's the inside there. And it's obvious it's got the brackets around it. Now this one here also has brackets around it. So a fraction, a square root bar, or a cube root or fourth root, any third bar means there's a bracket around the inside. Now you don't have to write it because that means there's the end of the bracket. Let's have a look what's going on. Most people will be okay. The sine just turns into a cos and the inside stays the same. So the inside stays the same. I put this little double back arrow going down there to remind people that the inside stays the same. Now, most people don't have a problem with that. They have a problem with this. Now, first of all, the 2, I call it stays there for the ride. It was a 2, it stays a 2. It just has no effect on it, doesn't change because it's still just a 2. So let's have a look at what we're talking about here. I talk about what we forgot and I put an arrow over and over with my classes. I'm always putting an arrow there to say what we forgot. So it's easy, so easy to do that question, and I've seen, oh my goodness, thousands of students who will just write 2 cos and they've forgotten that. This is more complicated than if you didn't have the 3 there. So if we didn't have the 3 there, talking about the gradient, this is talking about the gradient all the time. Everything we're talking about is a gradient of a tangent to a curve. So if we had a curve doing that and we wanted at that point, we're getting the gradient of that tangent at that point, or in this case, any point. So y dash means we're calculating, or we're able to calculate the gradient at any point. So what do we forget? This is actually 3, I talk about it being 3 times steeper. Now if I did that graph and showed you that graph with the 3x back in, let's put that 3x back in. If I showed you that graph and I showed you this, and I showed it without the 3, this graph will be steeper than the graph without the 3. So let's have a look what's happening. All we're doing is we're saying 2 3s are 6, and it's a cos of 3x plus 1. So it's a derivative of the inside. So we're talking about the gradient. So this 3 is talking about the gradient of that inside section, which makes the graph steeper. So a lot of people can look at it and just go, sine becomes a cos, 3 2s are 6, and leave the inside the same. Now if you're that confident, you can do it that quick. So y dash, talk about e's. E's stay the same. Not only do the inside stay the same, but the actual e itself stays the same. So you write the whole thing down. If I look at an e question, I go, yep, I write that down. Now normally that's not worth any marks because you haven't shown that you understood fully what was happening. I suppose it should be. Depends on who the examiners are and what they're expecting from you. Now, I've got my little arrow, which means what we forgot, or what I see people forget all the time. We times by the derivative of the inside, which is a 4. So that's, I'm going to nag about it, that's the derivative of the inside. So there's the question done. But then we can simplify, that's a numerator and that's a denominator. So if we cancel them out, 2 5s are 10, and we've got 10 e to the 4x. Now, hopefully you'll be confident enough, you can just look at that and just go, 4 5s are 20 divided by 2 is 10, and e stay the same and the inside stay the same. Question's done. I like these, they're so easy to do. Now, if you haven't done natural logs as yet, if we had a log with a base of, say, I don't know, say a base of 10. Say we had 3 log a base 10x minus 7. It's harder to do, it's more tricky, it's not as simplistic. So we talk about a base of 10, 10 fingers, 10 toes, work on everything a base of 10. But what we see in nature doesn't work on a base of 10. It works on a number called e. Now hopefully you've already seen that e, as we've seen here, and you understand what it is. But it's just a number, just like pi. So just like pi is 3.14, let's estimate it 1.2. And e is about 2.7. I could go more decimals, but not for now. Let's have a look what happens with it. Because it's a natural log, so it's the log of the natural, the log of the natural log. Here's the rule. Let's say you've never seen a natural log, don't understand and don't know what's going on at all. You can still apply the rules. That was a numerator. 3 is a numerator, so it stays on the numerator. And then, the incredible part is when you're differentiating natural logs, you just write the inside on the bottom. You write the inside function, the function that's in here, this function here, which is actually a linear function in this case, a straight line function. The inside's a straight line, you just write it on the bottom. And the incredible part is then you can just go, what did I forget? I forgot to multiply by the derivative of the inside, which is 10. I could say again, if I didn't have that 10 there, it wouldn't be as steep as a graph that did have a 10 there. So you could use graphing programs, like you can go onto the internet. You can look up Desmos. If you haven't seen Desmos before, oh my goodness, go look up Desmos and muck around. So even type in graph 3 ln x minus 7, and also on the same graph, put it in as graphing 3 ln 10x minus 7. Have a look at the two graphs. You can see that the one with the 10 is much steeper. So there's the question done. So we need to tidy it up. We go numerator, numerator, cannot cancel those 10s. I see so many students cancel the 10s. You can't cancel because there's a subtraction involved. If you really want to fuss about it, there's a bracket around it. And so that 10 can't just cancel with one part of the brackets. Let's have a look at what we've got now. So we've got a 30 on 10x minus 7. Now, if you're confident with it, you can look at that question and go 3 10s are 30, and then put that on the bottom and the question's done. It's just so easy. Now, watch out for the trap. Of course, it could have a square in there, which would make it more complicated. Now, the big one. I talk all the time about rearrange. In other words, go back to this. We knew what to do with a sine. We knew what to do with an exponential. We knew what to do with a natural log. But we don't know what to do when we've got a square root. Hopefully most of you have seen it before. And we rearrange first. And I've seen so many students over the years rearrange that and they put 6, 4 minus 3x to the power of a half. Now hopefully all of you are okay. Square root's just a half. Now the question's not done. But I've seen students write dash there, times it by minus 3, and they think they've done the question. No, they haven't understood. All we're doing is rearrange. So it's quite interesting. Some years ago, a long time ago, I started writing the word rearrange and nagging people about rearrange and put the arrow in. And the difference in my students was massive. So many students got it right and didn't have a problem with the question. So if you've never seen someone explain it this way, you write that as a half, and that's rearranging. So we've done nothing to the question. We've just changed the look of the appearance of it. Because we know when we have a half. So if we had, for example, x to the half, we can just differentiate it and put a half times 1 is a half. Instead of having a half power, we subtract 1 and we've got minus a half. So we're going to apply that principle here, but it's complicated. It's more complicated. How much more complicated? That much more complicated. And again, if you go to Desmos, you can put that in, and then you could put it in without the 3 and see what happens then, see the difference in the graph. So now we can differentiate because it's in the correct form. We're just going to go half times 6 is 3. The inside stay the same, nagging, nagging, nagging. The inside stay the same, twice to so much. Then we subtract 1 from the half, just like we did over here. So that's a minus a half. Sometimes I do put an arrow there, but it gets cluttered. Then we're going to put the arrow in and say, and get rid of that for a moment. Times by, and what's the trap? Times by minus 3. I've seen student after student just times by 3 and forget to put the minus or the negative involved in there as well. let's have a look at what we've got the questions done. So the derivative is minus 3 times 3 is just minus 9. Now, by the way, I'm going to say it again, that's a numerator, and that's a numerator, so they don't go to the bottom. The only thing that goes to the bottom is this part here. So it goes to the bottom, so the negative means it goes to the bottom, or, if you want to talk properly, it goes to the denominator. So everything that's written with that minus half on it, which is that whole bracket, will go to the bottom. So I'm going to go to the bottom, go to the denominator, I'm going to write my 4 minus 3x, but then the half means that it's a square root. So we put the square root back in, and the question's done. So if you wanted to do the shortcut on that, it's pretty tricky. I just don't think it's worth it. I personally just rearrange it to that, and then if I wanted to, I could shortcut it. I could go the half times the 6 and do it in my head. But again, I think it's not worth it. For me, when I was doing assessments, I make so many mistakes. I had to eliminate it. By the time I got to the end of grade 12, year 12, I eliminated a lot of my mistakes so I could get 95% plus. Did achieve 100% a couple of times by getting rid of my mistakes. One of the ones that annoys me most of all, that I still remember, and it's a long time since I did my grade 12, my year 12 exams, was I think I had 2 times 3 and I wrote 5, which is one of those just crazy things you do under pressure, or you just slip. It's like accountants turn numbers around. You're going to write, say, 37, you write 73. In our human nature, we just do it. So I would have written that, then I would have written that, and then I put the answer there. And I know I'm going to make less mistakes. Wow, I hope it helps. This topic can go on and on and on with crazy possibilities. So I call it Mixture 1. If I get around to it, I'll put on my playlist that I'll put the Mixture 2 and maybe a Mixture 3. But I do cover a lot of the other situations in the other videos I got. So I'm not sure whether I even need to make a new video. This probably shows you enough about it. Thanks for watching. Bye for now.